Geometries. What are they and why are they so important in Three.js and React Fiber? Geometries are being used to create shapes like this cube. In 3D terms, a shape consists of faces, edges and vertices. One piece of surface of a shape is called a face. The sides of this face are called edges. Those edges are connected to specific points which are called vertices. For demo purposes, we used this cube, but actually, geometries are not visible by themselves. They need to be made of some kind of material, just like in real life. If this doesn't make sense to you, then ask yourself if you've ever seen an object that's not made of some kind of material. Now to make things visible in the browser, we will keep using our orange mesh standard material. In another video, we will dive deeper into materials themselves. Because we are going to demonstrate multiple geometries, let's add the axis helper to see the different axes and change the lighting a bit by increasing the intensity and adding another light. Now that everything is set up, let's change our rotating box to a sphere. To figure out how to do that, I often hear people going to the React Fiber documentation, which makes sense. They mention that it lacks documentation because, for example, geometries are not really mentioned there. But this is actually not the case. React Fiber handles a lot dynamically. The documentation describes that the general rule is that fiber components are available under the camel case version of their name in Three.js. This means that a Three.js box geometry becomes a camel case box geometry JSX component in React Fiber. This also works for all other geometries. Now that we know that, let's go to the Three.js documentation and find our sphere geometry there. As you see, for most of the geometries, you can get an interactive demo to try out the different properties of that geometry. Below that, you will find a short code example and extra documentation about the class. For now, we can focus on the code example. On the first line, it creates a new sphere geometry. Let's do the same, but change the arguments so it fits to our scene. Currently, you only see the faces of the geometry, which together create this sphere. But if you actually want to see the edges and the vertices, we can add a wireframe property to the material. Now you can see that the sphere already contains a lot more vertices than the cube that we saw before. To change the amount of vertices, you can edit the arguments. Because we are using TypeScript, we can get to see the available parameters by pressing Ctrl space next to the property. As you can see, we can fill a radius, the amount of width segments, height segments, and some other properties. By changing those, you will get to see we get a different result. In this case, we changed the phi length, which will give us half of a sphere. More documentation about each property, like this phi length I just mentioned, is available in the Three.js documentation website. Let's take a look at one more geometry. This one is a bit more difficult because we have to define the shape ourselves. Let's copy the code from the example and use this as our base. Create a function getHeartShape and paste the code. Change the sphere geometry for a shape geometry with our newly created shape as argument. This will not give you the heart you expected because the argument we provided was invalid. The current result that you see is the default shape for a shape geometry. This happens because we didn't return our heart shape. Now it works, but the heart is too big. So let's scale it to 10% and remove the wireframe to make it more visible. The heart will now be visible on one side only, so let's change the material side to double side. After that, the only thing left to do is center the shape. Change the X and Y position and there you have your shape, which you have full control over. There are many other geometries available besides the sphere and shape geometry. Some are easy to implement, just like the sphere geometry, some require additional code. I definitely recommend to click through each of them in the Three.js documentation and play with the interactive demos. Some of the more difficult geometries that I think are worth experimenting with are the edges, the extrude, the torus knot, and the tube geometry. In case you want to create even more complex geometries, you will probably need to use some sort of 3D modeling software like Blender. In a later video, we will import an existing 3D model into our scene. Curious how that will look like? Then subscribe to the channel, and if you liked the video, please click the like button down below and I will see you next time. Ciao!